I need to graph the paths traced by the two particles, and they do have them graphed on the same grid. I'm going to go with, I guess, a chart like I've done the others. I'll have t for the first particle. X sub 1 is 4 sine t. Y sub 1 is 2 cosine t. And then I'm going to have an xy pair, which would be x sub 1, y sub 1. I'm going to pick the quadrantal angles, pi over 2, pi, 3 pi over 2, 2 pi, and 0. And then that might tell me if I need to pick some other angles as well for t. But I'll start with these. And so I'm thinking, since this is a multiple choice question, that's probably going to be enough to pick. So when t is 0, the sign of 0 is 0. So that's x sub 1 equals 0. When t is pi over 2, x sub 1, well, it's pi over 2, sine of pi over 2 is 1. 4 times 1 is 4. When t is pi, the sine of pi is 0. When t is 3 pi over 2, negative 4 for x sub 1, and then this last one is 0. In the cosine column, when t is 0, the cosine of 0 is 1, so y sub 1 is 2 times 1, which is 2. Then when t is pi over 2, this would be 0. When t is pi, negative 2, this one is 0, and the last one is 2. So the pairs are 0, 2, 4, 0, 0, negative 2, 4, 0, and 0, 2.
Negative 4.
I missed the negative 4. Thank you. Okay, negative 4. So for the first particle, the first parametric curve, I'm going to get this sort of picture. I'm going from 0, 2. That's not the right spot, is it? Not by any means. 0, 2, right here. 4, 0. I'm going to start on a new graph. 0, 2, 4, 0, 0, negative 2, negative 4, 0, and then we're back to 0, 2. So I want to indicate the direction of travel. And I meet up right there. So there's the first particle. The second one, I'll do that one on the chart on a new piece of paper. So we'll have values for t. X sub 2 is negative 4 plus cosine t. And y sub 2 is 1 plus sine t. Then I'll have a pair x sub 2, y sub 2. And I'm going to pick the same values for t. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I plug in 0, cosine of 0 is 1. So x sub 2 is negative 4 plus 1, that's negative 3. When t is pi over 2, the cosine of pi over 2 is 0, so it's negative 4 plus 0, and that's negative 4. When t is pi, the cosine of pi is negative 1, so x sub 2 is negative 4 minus 1 is negative 5. For 3 pi over 2, that is cosine of 3 pi over 2 is 0, so x sub 2 is negative 4 plus 0. And then for 2 pi, the cosine of 2 pi is 1, x sub 2 will be negative 4 plus 1 is negative 3. And then for y sub 2, the sine of 0 is 0. So y sub 2 is 1 plus 0. The sine of pi over 2 is 1. Y sub 2 would be 1 plus 1, that's 2. For pi, y sub 2, the sine of pi is 0. So 1 plus 0 is 1. 3 pi over 2, the sine of 3 pi over 2 is negative 1. Y sub 2 is 1 plus negative 1, that's 0. And then 2 pi, I'll get y sub 2 is 1. And then my ordered pairs, negative 3, 1, negative 4, 2, negative 5, 1, negative 4, 0, and negative 3, 1. Let's see. Let me plot those points on this graph. I'm going to go in a different color. So negative 3, comma, 1. Now I don't really know if it's coinciding with that graph at this point. Looks like it might. Let's see, negative 4, comma, 2. Negative 5, comma, 1. And negative 4, comma, 0 right here. Oh, I marked the wrong one. Thank y'all. Okay. Negative 4, comma, 0. And then, so I got this. Ignore that extra point there. Looks like a circle right there. And if I look on WebAssign then, it is, of these choices, it is the first one. There are 2 points of intersection. And I think there's more to this question, right, Paul?
Yeah, that was my question.
Yeah. How many points of intersection are there? There are 2. Are any of these points collision points? In other words, are the particles ever at the same place at the same time? And you can see from the computer the answer is yes. And then it says, if so, find the collision points. Well, I'm going to go back to my chart right here. And if I look, when I did 3 pi over 2 for the first particle, I got the point negative 4, 0. And then at 3 pi over 2 for the second particle, I got negative 4, 0. That happens at the same time, so that's the collision point. And that's indicated. I'm going to go back to the computer screen. And then it says another question, if the x-coordinate is given by, for the second particle, x sub 2 is 4 plus cosine t. Instead, is there still a collision? And you can see my answer up there. I'm going to not work that part of this problem at this point. I want to have time for other questions if you have any others.